Thank you very much for the kind introduction. I'm very glad to be here. And this talk is the first talk that is summarizing actually the work of many years of thought about crises that we have involved and the question, why do we have so many crises? Do we need a different kind of thinking about systems? And the answer is yes. Well, if you look around us, we see a lot of social order around us. So here, for example, you can see the people are walking in lanes in different directions. These lanes are separated from each other. That makes the interaction between pedestrians efficient. And so it's a little bit like a magical self-organization that goes on here, as if there was an invisible hand that would actually create order. And this basically has guided the thinking through centuries. In fact, the institutions that our societies and our economy are built on are 300 years old. And one of the major ideas in this connection was the fable of the bees, which basically was promoting the idea that our society and our economy could really self-organize, very much like a beehive. There is nobody who would really tell the bees what to do. They do have a queen, but the queen doesn't give any commands. So that also has inspired this concept of the invisible hand that is attributed actually to Adam Smith. And so the idea is that if everybody is just deciding and acting according to his or her best interest, that would also maximize the social benefit. And so it's a little bit like there would be God in the background who would pull the strings and make sure that everything works out well. But unfortunately, it's not always the case. This is an example of crowd disasters. That's a crowd disaster that happened in Duisburg in Germany. 21 people died, more than 500 were injured. And I've done crowd research for many years and can say nobody here wanted to hurt anybody. This is a situation that got out of control, that nobody could actually influence. And if you don't believe it, I'm showing you another example to make it much clearer, which is traffic flow. We all, many of us, have driver's license or have passengers in cars. So it's not so difficult to drive a car, and the task here is just to drive in a circle, keep the speed constant, avoid accidents. And what we see is that after some time, actually, this beautiful circular pattern of free flow breaks down, and now we have a traffic jam that has formed. This traffic jam is propagating backward against the driving direction, and it would always appear when the density reaches a certain level. So now, if you would ask the drivers what was the reason for this, they would say, hey, there was a stupid driver in front of me who didn't know how to drive. And this is not the explanation, however, of unstable traffic flow. The explanation is that if the distance to the next car is small, then considering the time it takes to adapt to the variation of speed of the driver in front of you, there is a delayed adaptation, and to compensate for this, you have to brake a little bit harder. That means your speed will be slower than the speed of the car ahead. And it will be a chain reaction. Of course, the next driver has to brake even harder. In the end, traffic gets to a standstill, although all drivers want to move forward quickly. That means we have here the phenomenon of the systemic instability, where all the people are well trained, they have good equipment, they're trying hard to avoid this, but still it's unavoidable, and there's a breakdown of traffic So this is kind of the prime example illustrating systemic instability. We have to be aware that if we operate systems in the wrong parameter regime, then they would get out of control sooner or later, even if we try hard, even if we would have the best technology and all the data. So we need to make sure that we design and operate systems in a way that this wouldn't happen. Because wars and revolutions and financial crises are all of this type. Here is actually a computer simulation of a situation which is very important to understand the problems that we're having. It's called the social dilemma situation. People in red are those who don't cooperate. People in blue cooperate. We see that local interaction promotes cooperation. But then eventually, once we network those people or banks or companies more and more, there will be a certain level of connectivity beyond which cooperation destabilizes. It means it breaks down. And I consider this actually the prime, the root origin of the financial crisis, of the financial breakdown some years back. What is the problem here? Well, in a social dilemma situation, it would be good if everybody cooperated. But if all the others cooperate, we don't, we have an additional advantage. So there's a temptation to defect, and there's a risk to cooperate. And that destabilizes cooperation. This is what we've seen over here. And we need to be aware that as we go on networking our world and promoting globalization, this is actually a danger that we're exposed to. It's not just a special situation. Many economic interactions are this kind, because we would always claim that the value of a product would be higher than it actually is, or that the risk of a financial derivative would be smaller than it is. So there is always this temptation to make a little bit more profit. And so we have social dilemma situations all around. And here are some others: global warming, environmental pollution, overfishing, and environmental exploitation, tax evasion, free riding. There's a long list of social dilemma situations, and you can see quickly these are the situations where we tend to lose control, where we have real difficulties to solve the problem. And so this is the reason basically why self-organization is not doing this wonderful job as this invisible hand paradigm promised to do. And for that reason, there is another concept that goes back to Thomas Hobbes, which is the Leviathan. And in the Leviathan he says, the selfish beast of the human. He was using the term homo hominis lupus. It means people are behaving to each other like wolves. So to tame the selfish beast requires a very strong state, basically, that creates social order. And so this is the intellectual basis actually of regulation by politics, which is kind of struggling with the self-organization in the economy. And as a consequence of that, we have, for example, taxes. Some taxes are, of course, used to pay for infrastructure and so on for public goods. But in some sense also, we try to provide incentives to people by taxes to do certain things, for example, to invest into environmental friendly energy production like solar panels, or to avoid certain behaviors such as smoking. And in this way, basically, the social dilemma game is changed to another game, which is not anymore constituting a social dilemma situation. But we have seen in the case of carbon taxing that the taxing scheme was actually not fulfilling its job as expected. So maybe we need something else. We also have a very powerful state in order to enforce regulations that people would behave properly, and we have a lot of laws, more every year, hundreds, thousands, tens of thousands of regulations actually, and it doesn't come free of charge. Well, there is a situation where many people say we are over-regulated, and over-regulation is basically costly for both sides, for the regulator and for those who are being regulated. It produces inefficiencies in the system. And actually, you can't really pay for this anymore. This is the debt in GDP. And you can see there are some countries that have about 100% or even more debts than GDP. And basically, many industrialized countries are in a very difficult situation. I've never heard any politician explain to me how we would never be able to pay back the debt. So this could just be a sign of a systemic crisis, that we need to change our thinking. And so how would it be if we learned to self-regulate the system, bottom up? There are so many examples where, to a certain extent, this is working. Ants are a beautiful example. Here you can see that they learn to take the shortest passes between the nest and the food source. And this is all based on decentralized mechanisms. So it doesn't require police, it doesn't require laws, it doesn't require any top-down regulation. It's all regulated automatically. And in fact, there is a trend towards decentralization. That has a certain logic, of course, as systems become more and more complex. I will argue, I will give you an example later, it's not possible to optimize that anymore. And that means we need to have a different approach. We need more decentralized elements. We see that, for example, in the organization of smart grids. That's going towards decentralization. The internet has always been quite decentralized, and I've shown you now that this is also a success principle for traffic light control. But before, here's a beautiful example from crossing the beach. You can see many different kinds of agents, like bus drivers, car drivers, people who have a donkey, or even pedestrians, who all manage to get along with each other well. And there is a small trick over here, which is this small buffer between the two unidirectional roads that allows people to adjust in the way to arrive just in time to use the gap in the traffic flow. In effect, this using gaps as opportunities rather than planning traffic light control is also the approach that we have been following. So I will compare now three different kinds of traffic light control, and you could also see them symbolic for the way you can govern a social system, or you can actually manage an economic system. So it would be possible to have a top-down optimization. There's a central traffic control authority. Then you could have locally optimized traffic flows where each intersection is trying to minimize waiting times. And there would be a bottom-up self-regulated traffic, which would also take into account the impacts on the neighboring intersections. So you can see over here we have been inspired by oscillatory traffic flows of pedestrians and bottlenecks. This very same self-organization principle has been applied here to the self-organization of the intersections. And the movie has shown you that it automatically creates green waves by self-organization. These are not green waves that have been imposed on the city traffic after previous planning or optimization. We're using here also information of arriving flows, so we can do a short-term forecast and in this way try to keep vehicles flowing as much as this is possible without conflict with crossing flows. But this works very well, and here is now a comparison of the performance of the different approaches. So let's start with the optimal periodic service. So the approach of optimization is that we try to synchronize the different intersections with each other. Unfortunately, you cannot do real-time optimization in a large city because there are so many degrees of freedom, so many parameters that you can change that even a supercomputer cannot do that in real time. It's an NP-complete optimization problem. Computational time is slow, it's basically just the size of the problem, the number of intersections. So you would basically come up with an optimal traffic light control for the typical traffic flow on Monday morning between 9 and 10 or on Friday afternoon between 15 and 16 hours. And the problem here is, however, that the variability of traffic flows is as big as the average traffic flow. It means there is no representative traffic flow. Each situation is different. That means your optimal control is not optimal for the actual traffic situation. That's why this centralized optimization does not deliver best results. We can try local optimization, where each intersection is strictly minimizing the waiting times, as a Homo economicus would do. A selfish optimization, basically. And you see it works well. It's the violet curve with very short queue lengths up until a certain capacity utilization. However, then side roads are not served frequently enough, and the length of queues basically grows and grows and grows, and that would sooner or later create spillover effects, obstructions of neighboring intersections, and large-scale congestion. Now, we have added to this local waiting time minimization another rule, which basically makes sure that long queues are cleared when they have reached a critical length. And that creates self-regulated traffic flows. You can see that creates superior performance all the way for all possible capacity utilizations by considering the impact on neighboring intersections. Okay? So now we have a comparison between these three different strategies, and this last considerate other regarding strategy will be called the Homo socialis strategy for reasons that we all understand soon. Just saying that this is not working only in a computer. We have done a real case study with real flow data in Dresden, in the center where there's a very complicated traffic situation. And many public transportation vehicles actually cutting through this area, thereby creating problems to set up green waves. And they're really in big trouble, and of course they were not satisfied with the situation and said, okay, show us how well you can perform. And here's a comparison. On the left-hand side you see the current traffic light control. It creates green waves, and it's also adaptive. It means it's really a state-of-the-art control. However, on the right-hand side, the performance is better. The trams are served earlier. We have smaller queues of vehicles, and we have also, of course, a systematic evaluation. You can see, surprisingly, can create advantages for all the different modes of transport, for public transport, for motorized individual traffic, for pedestrians and cyclists, and also for the environment. I mean, it's in favor of sustainability, and travel times, by the way, also become more predictable. That means it just has advantages by going away from top-down regulation to bottom-up self-regulation. And now what does that mean actually for our economy? Some years back we had the financial crisis, and we're not over it. It's not solved, I would say. And I brought you a number of quotes of people who are really well respected. Paul Krugman is a Nobel Prize winner, and so he was asking, how did economists get it so wrong? Alan Greenspan was really questioning the knowledge of economics very seriously. And Jean-Claude Trichet, the previous president of the European Central Bank, said, when the crisis came, the serious limitation of existing economic and financial models immediately became apparent. We felt abandoned by conventional tools. So do we have the right approach? Does economics work in good weather conditions but not market storms? It would be like a traffic model that explains free traffic flow but not congestion. So certainly we need to be able to understand financial pressures. And maybe we have to take a different route. Albert Einstein said we cannot solve our problems with the same kind of thinking that created them. And in many cases we don't even see what the problem is. We're not asking the right question. We're not following the right process. Take this cat. This experiment has actually been done with pigeons, by the way. This cat, we assume, has been raised in a cage with vertical bars. And then after some months, we put it in a different cage with horizontal bars. And it will literally not be able to see the bars. As I say, it was not done with cats, but with pigeons. And humans are the same way. We see the things that we were raised to see, and we don't see other things that might be very important to understand. And I'm showing you here the emergence of the Homo socialis, starting with a situation where we have just the Homo economicus. That means we were testing the hypothesis, which is the basis of all mainstream economics, which is the Homo economicus, the self-regarding optimizer, the selfish person. So they're all starting with the defection, red and orange. We have two families, that's why we distinguish between red and orange. You can see after some time green and blue pops up, because there's an emergence actually of cooperation, and that is related with the circumstance that we now have actually the emergence of a Homo socialis who is other regarded. Now I don't have enough time to explain the assumption of this model, but all the underlying rules of the simulation are neither in favor of cooperation nor in favor of other regarding friendly behavior. So we start with everybody being nasty, we start with everybody being unfriendly. We do have a genetic inheritance of friendliness with some mutation. Without mutation, it would not be possible to find friendliness. But despite all assumptions that would actually be in favor of the Homo economicus, we now find that there is a chance that the Homo socialis would actually exist besides the Homo economicus. So we could not imagine this to exist because the standard thinking is what else could happen besides a Homo economicus? If we behave friendly to others now, we basically give away advantages, and natural selection would sort us out, and after some generation we just have people of the type of the Homo economicus. And actually this is true for most of the parameter combination. All the red dots over here correspond to an outcome of the Homo economicus. But there is a small edge down there with blue dots, which corresponds to the emergence of the Homo socialis. He is actually, or she is, emerging when there is small intergenerational migration. It means if the children, the offspring, stay close to their parents. And that's something which is not an unrealistic assumption, and in fact there's a lot of experimental and empirical evidence that speaks in favor of the Homo socialis. So maybe we should really build economics on economics, different starting point, a different theory. By the way, the Homo socialis is even performing better than the Homo economicus. The cooperators are in the end getting more payoff. That means we are really doing a bad job if we behave as a Homo economicus, because we run in a tragedy of the commons, such as the global warming, overfishing, and so on, as I mentioned before. So we can understand why this is happening. Because we have created institutions for the Homo economicus. And the Homo socialis is actually not striving well under such conditions. We would have to come up with institutions that are fit to the Homo socialis. Here you can see, by the way, how the friendliness evolves over time. So in the beginning, as I said, nobody is friendly, but after some time, there is quite a degree of friendliness, and that fits very well to experimental results of Ryan Murphy. It's also here in Singapore many times. So this theory is more consistent, I would say, with empirical observations in the Homo economicus. We could just not imagine that there was something else in the Homo economicus. That's why all our economics, hundreds of books, were basically built, with some exceptions that we would give on this assumption. Even Adam Smith actually believed in what I now call the Homo socialis. Read here, the theory of moral sentiments, he wrote, however selfish man may be supposed, there are evidently some principles in his nature which interest him in the fortune of others and render their happiness necessary to him, though he derives nothing from it. So had we read Adam Smith more carefully, we could have maybe saved 300 years of pain. So in principle now, we have to say there is an economics for the Homo economicus. We know a lot about him. But on the other hand, we would have to create a science to understand the Homo socialis better. And I'm calling this the socionomics actually. And this science still needs to be created. Now, when talking about institutions that would help this Homo socialis to exist and to thrive, we have to think about mechanisms that can overcome the tragedies of the commons. That means mechanisms that can solve social dilemmas in relations. And there are a number of mechanisms that we know from scientific investigation. One is genetic favoritism. It means that we basically give advantages to family members. And we know that was actually the first way of humans to organize themselves. There are huge family clans in some countries, and of course we had kings, dynasties in many countries. So this was the principle that we used early on. But there's also another approach, which is reciprocity. So I help you if you help me. While the previous mechanism actually of the genetic favoritism tends to create ethnic war and conflict, this mechanism, however, might create corruption. So it also has some negative side effects. We're now investing a lot into surveillance technology, into strong governments in many countries in the world, because we feel our society and economy are destabilizing. And as I told you before, this is because of this increasing degree of networking, increasing complexity, and other trends in our globalized world. So, punishment of deviant behavior is one way of stabilizing cooperation, but nobody loves it, and it's a centralized mechanism. So I believe it will not work as societies and economies become more and more complex. Growth of complexity, however, is the natural path of history. We find it also in nature. So I don't think that will be the final solution. So what other solution is there? Before I get to this, I would say, okay, surveillance also is not a good solution because we would start to censor our own thinking. It would be just a few thoughts left that are kind of acceptable from a public point of view. It would very much limit our creativity and innovation capacity. In fact, The Economist had an issue recently about innovation. And they said, okay, when would we ever come up with good innovation, useful inventions again? So the economic crisis that we see in a number of countries in the world is partly because of lack of diversity. Diversity is the main driver of innovation. And just to give you a quote of somebody who's part of the financial system, Andrew Haldane of the Bank of England, he says modern finance is complex, perhaps too complex. Regulation of modern finance is complex, almost certainly too complex. That configuration spells trouble, as you do not fight fire with fire, you do not fight complexity with complexity, because complexity generates uncertainty, not risk. It requires a regular response grounded in simplicity, not complex. So that means there is no other way, sooner or later, to get towards decentralization and bottom-up self-regulation. And that means we're going to make a step towards a new society and a new economy. It all started with a central planner where organization and regulation happened top-down. We know that was not very efficient, actually. And so bottom-up organization came up and is coming up in other countries. That increases the efficiency of the system. And that corresponds to conventional market society. I do believe we are on the way into a participatory market society, which is basically built around the homo socialis rather than the homo economicus, where both organization and regulation will happen in a bottom-up way, thereby again unleashing a lot of creativity and efficiency. And how to do that? There is one mechanism that we control, which is reputation. And we see, besides surveillance, actually, reputation systems are growing in the web very quickly. So Facebook likes all over the places. People now rate products, companies, politicians, professors, everything, information. So that will spread more and more and will guide the way, basically, to take decisions whom you want to interact with, whom you want to make business with. And in fact, you can make better business with reputation. It turns out at eBay that those sellers who have a higher reputation can sell the very same products at a higher price. So it pays off both for customers and for sellers. A reputation is a good business model. And here you can see it's really used as a mechanism today. We know it also from Amazon. Amazon is recommending us books based on books we have ordered previously. And that's fine, but I think we need to get towards a system, again a decentralized reputation system, where there is not one company or one other institution that is deciding for us what the books that would interest us or whatever might interest us. We want to be the people to decide about how to evaluate recommendations of others. That means we want to have control of the information filters ourselves. And that means speaking about science. I would like to have recommendations of other people's publications, for example. But I would not just want to have one filter. I would want to have one that tells me this is the most popular papers this week, but also these are the most controversial papers, or these are the papers that your biggest competitor is reading, or those are the papers that the most admired scientist of myself is reading, or whatever. So I would have 10 different filters, you would have 10 other filters, and so on. You would share those filters, you would change those filters, and in this way, an information and innovation ecosystem would actually come up, where we have all filters which become better and better because we all are changing them all the time, and we're using just the ones that we find useful. So a decentralized reputation system which has multiple criteria, not just one-dimensional criteria, because some people like slapstick comedies and other people like them. Some people like to have a big car, others prefer a small car, and so on. So what constitutes quality for you might not be quality for me, or the other way around. So we all have our special preferences. And also, this is very important because these recommender systems that we have today create something like a filter bubble. That means we just get to see the stuff that a company like Google thinks is the stuff that we would be interested in. But how do you know this is really the stuff we are interested in if we can't see the other stuff anymore? So we want to determine the search algorithm that brings up the search results. Otherwise, we're losing control about what we see and how we behave. So decentralization is important. I think also the reputation can be applied to the financial system. Since hundreds of years we have financial crisis. And I do think it's because money is a well-defined control system. It's basically one-dimensional, so it can only go up and down. That means bubbles and crashes are built in the system. And it's basically because money is memoryless. Now in mathematics we have many different kinds of quantities. We have scalar quantities, money is one of them, but we also have vectors, we have networks as well, and matrices and so on. So I do think we need to have multidimensional money, and we could have money which not just as a quantity, but also qualities. And the qualities would determine basically a conversion factor. And through a reputation of money, that means each amount of money would have a reputation, would be traded like a stock is traded today. And it might have a history. So that would have a big advantage. At the moment in Europe we have the problem that different countries cannot adjust the value of their currencies anymore. Now, did we have this qualified money that I'm talking about here, then again, money could adjust its value, so we could get rid of the problems that we have at the moment. We would have, again, many degrees of freedom that would allow the system to adjust as needed. Now, we are already actually on the way of this fundamental transformation of our society and economy. And prosumers are just one example. So we're talking here about co-producing consumers. That means rather than just selecting certain color of your car and some details of it, you might maybe start to create part of it, a certain design or so. And you would be able to produce it, to sell it. You could come up with all sorts of things. 3D printers will make that possible. You can sell stuff to your friends, to your colleagues, to your wider family members, and to everybody in the world actually. You could even build a team that creates complicated products, like not just a toy car, maybe even a real car. You have other engineers and designers and other people, and social media platforms will make it actually possible eventually to set up such kind of collaborative projects. So I do think that projects of this kind will actually be another kind of producing products in our economy. Besides, the companies of today will be much more flexible. That means we would basically look out for products that we would either participate in or lead, and once they're finished, we would start another project. So there would be a very flexible way of organizing ourselves, and we would come up with much more customized products which are catered to the interests of people. So I do think that opens up the possibility for an age of creativity, actually. It could be almost infinite dimensions of variability and creativity in production. And big data will fuel this trend. Big data will also help us to get better awareness of the state of the world, not only of the biological and physical state, but also of the social situation, the economic situation, that will help us to consider not just GDP, but also happiness, for example, health, environment, and many other things, which is very important to increase sustainability. Now, these kind of collaborative projects are on the way. They're around us. Wikipedia is just one example. GitHub is becoming extremely popular. And sharing as well. The sharing economy, as we call it, has a 20% growth rate, so you can make money with sharing. There are social media platforms of all kinds that will fuel this transition. There are actually hundreds of them. It's a whole universe. It's our own ecosystem. It's happening. So basically, we're making a shift from a situation where we have a centralized control towards a situation where we have decentralized control. No idea why there's no sound at the moment. So this also has implications for the arts and sciences. We are now experiencing a transition from a component-oriented view of the world towards an interaction-oriented, systemic view. And I think this is crucial. It will change our perspective of the world. It will result in different political and economic conclusions. It will create a better world, better tailored to people. And we now need to help people to understand this change in our thinking. So here is one example that I'd like to show you. It's about so-called flash mobs. I don't know what it's showing this anymore. Flash mobs. It would be even nicer, of course, with some sound. But let's see what happens over here. There's no pre-manufactured script. People were just said, okay, at a certain time, you freeze your motion for a few minutes and don't do anything else. But everybody could freeze motion as they would like to do that. And that became really something like an art project, as you can see now. So people stop, people freeze. It's almost a bit spooky, huh? Yes, people haven't seen something like that before. And everybody did a different thing, but together you created something like an art installation. And I do think art can make a major contribution actually to understanding the transition that you will see towards self-regulation. So I hope that would stimulate your creativity a little bit. I'd like to end as soon as these people get to life again. So this is the whole thing ends, and everybody is alive again. You can see how astonished people are and how excited. So there's one thing that we need to remember here. A single idea can spark off thousands of ideas, and I think we can make it happen. We can create actually a better world. A world in which we have self-regulation, where we behave in an other-regarded way, and where altogether we can avoid prejudice of the commons and come up just with a better, more livable world.